Use the trapezium rule with 5 ordinates to find the approximate value of the following function, giving your answer to 3 decimal places. It's the integral from 1 to 3 of 1 over the square root of 1 plus x squared dx. Now, I had worked this out before, and the answer I got was 1.090 square units. Now, I want you to pause the video, write the question down, and make an attempt at it. Genuine attempt. Don't look at any solutions, don't ask for any help. Alright? And if I didn't make a mistake, you should get that same answer, or very, very close to it. Okay. Did you get that same answer? Now let us look at the question here now. Let us do a little sketch. It's always nice to do a little sketch to get some visual picture of what you're doing. Now 1 over the square root of x squared. What is it? I don't know what it looks like. Let's say it looks something like this. You don't really care about the accuracy of your graph. Now, even if you draw it like this, or a straight line, right, you'll get the same thing, same answer. It's just rough work that you're doing here. Now with 5 ordinates, that means 5 straight lines of 1, 2, 3, 4, 5. All right. Let me space them out a bit now. 1, 2, 3, 4, 5. Okay. Now the thing is, you're going from 1 to 3. This is 1, and this is 3. That would be 1, 2, 3, 4, 5. You have this cut into 5 parts. From 1 to 3 is 2. So the width here, from here to here, is 2, right? 2 divided by 1, 2, 3, 4. 2 into 5. 2. Each of them is 2/5 wide. So the width from here to here is 2/5. But 2/5 is the same as 0.4. Alright? Now, if that is the case, 1, 2, 3, 4. Oh, is 6 alright, I draw? 1, 2, 3, 4, 5. Oh my. I drew 6 ordinates instead of 5. It's 5 ordinates. 1, that means 5 straight lines. 1, 2, 3, 4, 5. Right. So this should be here then. Now again, the width of this thing from 1 to 3 is 2. So if you have 2 divided into 1, 2, 3, 4 parts, 2 divided into 4 parts mean each of them is 2/4, which is half. The width of each of these, you call them trapezium, right? It's approximately a trapezium. It might look like this, and the curve here, well, you approximate to a trapezium. That's why they call it the trapezium rule, right? So each of them is half wide. So 1, go 1 half more, this would be 1.5. Another half more, this would be 2, half more is 2.5, and another half 3. Right. So we got the ordinates correct in terms of the x location, the x ordinates. Now, we have to remember what the trapezium rule says, right? If you don't remember, you have to go and quickly derive it. Let's say you have a curve. So you have these three, and you say this is height 1, height 2, height 3, height 4. So yeah, if you have 4 ordinates here, just quickly deriving it, right? Now, what's the area? Each of them have the same width. The area is equal to, the area for trapezium is the average of the two different heights. So the area of a trapezium is the average of the two different heights. If you have height 1 and height 2, it's h1 plus h2 over 2 times the width. Right? Now, what's the average of the first trapezium? Is h1 plus h2 over 2 times the width plus average, the thing there, the area of the second trapezium is h2 plus h3 over 2 times the width, and the third trapezium, you add it, so it's h3 plus h4 over 3 times the width. And then you remember, you wouldn't have to go through all this if you remember the formula, you know. This is rough work I'm doing here. Factor out the width and the half. The half applies to all of them. So it's half width in bracket. H1 plus H2 plus, and then this one H2 plus H3 plus, and then this one is H3 plus H4. So it is half the width times, you have H1, only one H1, because with this area is only one H1, and then H4 at the end is only one of them. In between now, when you added, well, when you found the first area, you use H2. When you found the second area, you use H2 again. So there are two of them, right? Plus 2H2 plus. When you found the second area, you use H3 as well. But when you found the third area, you use H3 again. So there are two H3s. Alright. So this is telling you that there's only one of the first ordinate, only one of the second ordinate, but you have 2 times all the others. This thing jump up like that. So what the trapezium rule says is the area is well, I should write approximately equal to half the width times the, if IRST first plus last plus twice the others. All right. So looking back here, this would be H1, H2, H3, H4, H5. Remember, these are the heights, not like the H's. The values of X is what you're seeing here. We want the heights. All right. What I could do is just label them at the sides then. This is height 1, height 2, height 3, height 4, height 5. So H1, H2, H3, H4, H5. We want to find each of them. H1 equal H2 equal what, H3 equals what, H4 equals what, H5 equals. Now we have 1 over the square root of x1 plus x squared. So this is 1 over the square root of 1 plus, for H1 is 1 plus 1 squared. For 2 is 1 over the square root of 1 plus 1.5 squared. For H3, you know that I need some more space. For H3, it is 1 over the square root of 1 plus, it would be 2 squared. H3 is at 2, then 2.5, then 3. H4 is 1 over the square root of 1 plus 2.5 squared. And for H5, it is 1 over the square root of 1 plus 3 squared, right? So let's quickly work them out and see what we get. One over the square, well, this 1 squared is 1. 1 plus 1 is 2. 1 over the square root of 2 squared. And remember that we are to write it to 3 decimal places. So during our work, we need to use more than 3 decimal places. I wonder if I could put it in basic mode to make it take up less space. So 1 over the square root of 2 is 0 point, and then we have all of this. Down there. So 0.7071, 0.7071. For H2 now, is going to be 1 over open bracket. Oh, so it's 1 over. Alright, let's do it like this. 1.5 square, 15, 15, 225. So it's 1 plus 2.25. You get that? And then the square root of that equal. Then 1 over that equal 0.5547. 0.5547. Okay. So that's what we have. After that, 1 over, well, this one shouldn't be so bad. We have 2 2's 4, 4 and 1 5. So it's 1 over the square root of 5. And we get 0.4472. Alright. 0.4472. Then this one now is 1 over square root of 1 plus 2.5 squared. 25 squared is 625. So this is 6.25 plus 1. That's going to be 7.25. Oh no, 7.25. The square root of 7.25 equals that. 1 over that equal 0.3714. Right? So we have 0.3714. So that's 2.5 squared, 1 plus that square root equal 1 over equal 0.3714. So we have H4 is 0.3714. Alright. Now, here. This one, 3 3 is 9, 9 and 1, 10. So this is going to be 1 over the square root of 10. 1 over the square root of 10. 1 over square root 10 equal 0.3162, 0.3162. 0.3162. All right, nice. So you see all of that, all right? Now here, let me do a little thing here. So here now, we have the width. What's the width again? Half. So the area is approximately equal to half times the width, which is half, times the first, which is 0.7071, 0.7071, plus the last 0.3162, plus twice the others. That's going to be twice 0.5547, 0.5547 plus 0.4472, 0.4472 plus 0.3714, 0.3714. All right. So we have the area is approximately equal to, this is a quarter, times, now we're going to have uh, 0.7071 plus 0.3162 equal 1.0233, 1.0233, 1.0233, 1.0233 plus 2 times, and then we add up what we have here. .5547 plus 0.4472 plus 0.3714 equal 1.3733. 1.3733. So we have that. Okay, which is equal to a quarter at 0.25 times, so we have 1.0233 plus 2.2 by that. This 2 times it gives us 2.7466, 2.7466. So what we have is that the area is approximately equal to 0.25 times, and then we add up these 1.0233 plus this equal 3.7699, 3.7699. 3.7699 equal, and then you multiply by 0.25, get 0.942 to 3 decimal places, 0.942 square units. All right, what did I give as my answer first? 1.09. Let me see something. Oh, I see where I made a mistake in my original calculation. Okay, it was here. I had put this 1 over the square root of 2.5 squared instead of 1 over square root of 1 plus 2.5 squared. That was a mistake. It's close still. If you're in exam, if I was marking and you made that mistake, wouldn't bother to take off any marks, because that is just an oversight, probably hurrying to finish up, right? But the important thing is that you know the steps and understand why you're doing what you're doing in working it out. All right, so you have 0.942. If you got something else or I got stuck, I'm going to ask you to try the question again. Write the question down and make another attempt at it without looking back at this video or without any other help. Alright, I'll see you in the next video.